Dear students, welcome back to the lesson on general theory of relativity. In the previous lesson, we have discussed what general theory of relativity is, how Einstein came up with the general theory of relativity, and some of the predictions of general theory of relativity. And in this lesson, we are going to look at some major predictions of general theory of relativity and explain what those predictions were and how those things play out. So, one of the major predictions of general theory of relativity was gravitational lensing. So, in the previous lesson, we have discussed that according to Einstein, gravity was not a force, rather, it is the curvature of space time. So, essentially, a massive body can warp the space time around it, and everything will travel only through this warped space time rather than through a straight line. So, gravitational lensing was a consequence of that effect. So, let's see what gravitational lensing is. So, the gravitational lensing occurs when light reaching an observer has passed near a massive object which is heavily distorting space. The light can be seen to bend around the body. So, imagine we have a star and the star is emitting light and the light is received by humans here on earth. While the light is traveling through space, imagine there is a black hole in the way of the light, and the black hole will obviously warp the space-time around it, and the light will have to go through this warped space-time around the black hole in order to reach earth. And sometimes we can see that the light that should not reach earth because of the object in front of us will actually reach earth because it can bend around that warped space-time, right? So let us see some examples or pictures. So here what we can see around the star, something like a halo, it is essentially the light from an object which is behind this star. Normally we wouldn't be able to see the light which is from an object that is behind the star, but through gravitational lensing the light will bend around the object in the front and reaches our instruments or our eyes. So this is essentially what we call as gravitational lensing. And in many of the deep field images, we can see streaks of light which are gravitational lensing. So there are points of light and then there are some curved lines of light here, etc. These lines are caused by gravitational lensing. So these are the lights that are coming from far away than these objects, and this is a result of gravitation due to the curvature of space-time. And there is another diagram here. So we have a massive object in the middle and the 4 points are essentially the same light coming from an object which is behind that object. So essentially the light from the source which is behind will curve around the object in the front and reach our instruments. And this is gravitational lensing, which was a prediction, a major prediction of the general theory of relativity, and which was proved through observations. One of the very famous predictions of general theory of relativity are black holes, which is a very famous topic. We all hear about black holes in science magazines, science podcasts, everything like that. So black holes, the concept of black holes doesn't really need an introduction from my part. So black holes are the most profound prediction of general relativity. So it is a large body of matter. So when I say large body of matter, it doesn't mean that it should be large. It essentially means that the mass of the body will be very high, or the density of the body will be very high. So it is a large body of matter that is so dense that nothing can escape its gravitational attraction. And by which we mean that in the previous lesson we have looked at how massive bodies warp space-time, and we have seen that Earth will warp the space-time only a little bit, whereas a massive star can warp the space-time even more, and a black hole can essentially warp the space-time infinitely so that nothing will be able to escape the warp of space-time of black hole. That is why we say that the black hole will attract everything, including the light. So black holes are a major prediction of general theory of relativity, and the existence of black holes have been proven through observations and stuff like that. Another prediction of general theory of relativity is called gravitational redshift. So gravitational redshift occurs when the light leaving massive bodies will show a redshift. So in physics, redshift is essentially the shift in wavelength towards the red region of spectrum, and the gravitational redshift is when light leaving a massive body will shift towards the red side of the spectrum in order to conserve energy. And if the body is falling towards a massive object, for the observer, it seems like the light is being blue shifted, or the wavelength of the light is being shifted to the blue region of the spectrum. So this has also been proved through observations. And another one of the major predictions of the general theory of relativity is gravitational waves. So gravitational waves is similar to waves that we see on a water body, on a pond, or a river, or an ocean, but here it is the fluctuation of space-time curvature. So we say that the space-time can be curved because of massive bodies, and the massive bodies will have the space-time around it in a curved manner, and when the massive bodies move, the curvature of the space-time is propagated as a wave, and this wave is called a gravitational wave. And the gravitational waves are produced when very massive body is accelerated, or when two massive bodies are collided. So all these massive bodies can cause gravitational waves, and the gravitational waves have also been detected through experiments that we conducted on Earth. So these are the four major predictions of general theory of relativity, and these predictions have all of these predictions have been observed or proved through observations and calculations. So I'll see you in the next lesson. Thank you.